Welcome to Brain Vision.
In this problem, it is given that the common isotope of uranium has a half-life of 4.47 times 10 to the power 9 years, decaying to thorium 234 by alpha emission. And using this, we have to find out the decay constant for the first part. Now, decay constant lambda is equal to natural log 2 upon half-life. Now the half-life is 4.47 times 10 to the power 9 years, and 1 year is equal to 3.154 times 10 to the power 7 seconds. So we multiply this by 3.154 times 10 to the power 7 to convert this into seconds. So the decay constant is 4.92 times 10 to the power minus 18 decays per second. Now for the second part, we have to find out the mass of uranium which is required for activity of 1 curie. Now we know that 1.00 curie is equal to 3.7 times 10 to the power 10 decays per second. So the activity is 1 curie, and activity is equal to lambda times the number of particles. So the number of particles will be activity upon lambda, and the number of moles will be number of particles upon Avogadro's constant, and mass will be number of particles times number of moles of particles times molar mass. So we have N upon times molar mass. N is A upon lambda times molar mass. Now activity is 3.7 times 10 to the power 10 decays per second, and decay constant is 4.92 times 10 to the power minus 18 per second. Avogadro's constant is 6.022 times 10 to the power 23 times molar mass is 238.03 gram per mole. So mass will be 2.97 times 10 to the power 6 grams. This is the mass, and now we have to find out the number of alpha particles emitted per second by 10 gram of uranium. So the number of moles is equal to mass upon molar mass, and number of particles will be number of moles times Avogadro's constant. Mass is 10.0 grams, and molar mass is 238.03 gram per mole, and Avogadro's constant is 6.022 times 10 to the power 23 per mole. So the number of particles is 2.53 times 10 to the power 22. So the alpha particles emitted per second is the activity, and this is equal to lambda times n. Decay constant lambda is 4.92 times 10 to the power minus 18 decays per second, and the number of particles is 2.53 times 10 to the power 22. So we get activity 1.24 times 10 to the power 5 decays per second, and the decay will be decay will be in form of alpha particles. So this will also be the number of alpha particles emitted per second. And this completes the solution. Thank you.